And one students, I've noticed through my checks for understanding that a number of you are struggling with the graphing the exponentials, and that's normal even in a normal environment in the regular classroom where students need a little bit more time to learn how to graph using a table of values with the exponential. So we're going to practice that some more today, but I want to be able to give you instant feedback. So we're doing this Edpuzzle format today so that as we build the table of values, we'll give you the answer after each one so that you can have instant feedback. Oh, yes, I'm getting this right, or I can see where I'm making a mistake. And we'll go over the graphing part as well. Most of you, you're making your errors in your table of values. Some of you are also making an error graphing, and we'll talk about that today as well. Here's our first one for today. We're going to do 4 problems. Okay, so first one is f of x equals 4 to the x. So we have an xy table, in this case x, f of x table, but f of x is the same as y. And we're going to substitute these values, -2, -1, 0, 1, and 2, in for x to get what the f of x value is. So I'd like you to start off. Let's do the first one. Let's start with the positive integers first. Let's do 4 to the second power. Can you go ahead and figure that one out? 4 to the second means 4 times 4, so the result is 16. So when x is 2, f of x is 16, or if we're going to plot this point, it's 216, means I'm going to go right 2, up 16 when we plot that point. Now I want you to substitute x equals 1. 4 to the first power is just 4. Okay, do you remember what the next one's going to be when we raise something to the 0 power? What's the value? 4 to the 0 gives us 1. Any number raised to the 0 power will always be 1. That's also our y-intercept. Oh, f of x equals a times b to the x. So in our problem here, what is the a value? It's 1. You don't see it. It's 1 times 4 to the x. The b is the 4. Okay, so if it's 1, we don't see a number in front of the 4 to the x, so we don't have to say 1 times 4 to the x. That makes sense? We'll see later on, I'll give you some different a values other than 1. So you'll see that soon. All right, the bugaboo time. Negative exponents. All right, let's do the -1, input that for x, and let me know what you get. So 4 to the -1 power, we're going to change that to a positive exponent. So to do that, we take the reciprocal of the base. Our base is 4 over 1. The reciprocal, you flip it, so it's 1/4. So it becomes 4 to the -1 becomes 1/4 to the positive 1 power. 1/4 to the 1 power is just 1/4. Okay, see if you got that one wrong, see if you can get this next one right. I want you to substitute -2 in for x, and what do you get? So 4 to the -2 power becomes 1 over 4 to the second power. That's positive 2 now. Okay, 1/4 squared means 1/4 times 1/4. 1 times 1 is 1. 4 times 4 is 16. So our answer is 1/16. Becomes 1 over 16. Now, graphing it shouldn't be that bad once you have the table of values. So I try to color code it for you here so you can see it. The first one, kind of the orangish color there, is -2, 1/16. So we went left 2, right, and only up 1/16. So it's very hard to do with the dots because it's so big. But it's really close to the x-axis. And then next one, -1, 1/4. The yellow one should be a little bit higher than the orange one. And then the blue one's my y-intercept, 0, 1. And then it becomes easier to graph. 1/4 is my purple one. The pink one is 2/16. Right? So now it starts to fly up. Right? So how would you generate the next one? If x is 3, what would you expect f of x to be? Answer that question. If we continue the table, we know we just take the previous value for y, or f of x, and you just multiply it by 4. So 16 times 4 is 64. So when x is 3, it would be 64. How about if we were going the other way? We were going this way. What's going on? Well, we're dividing by 4 each time as I go from bottom up, right? So 1/16 divided by 4, that's the same as 1/16 times 1/4. So multiplying by 1/4 is the same thing as dividing by 4. So we get, for -3 value, would be 1/64. So it gets so close. So this is what we were talking about. Our asymptote here is on the x-axis, and the ones we're doing in our class, the asymptote is on the x-axis. I want you to know that not all exponential functions have the asymptote right on the x-axis, just the ones we're doing in our class right now with the basic function. That's why they always have the asymptote on the x-axis. So it gets so close to 0, but yet so far it doesn't quite touch it. All right, let's do the next one. All right, this function is f of x equals 1/3 to the x power. So again, our a value is 1. So we expect our y-intercept to be at 1. It's 1/3 to the x. So let's start with the harder ones. Let's start with the -2 for x. Tell me what f of x is when x is -2. Did you get 9? 1/3 to the -2nd power becomes reciprocal, 3/1, or 3 to the 2nd power, positive. 3 to the 2nd means 3 times 3, so we get 9. Try when x is -1. So you should have got 3 here. 1/3 to the -1 power becomes 3 to the +1, which is just 3. All right, we know that 1/3 to the 0 power is 1. 1/3 to the first power is 1/3. I want you to do 1/3 to the second power now. Did you get 1/9? It's 1/3 squared, which becomes 1/3 times 1/3. Again, the numerator, 1 times 1 is 1. The denominators, 3 times 3 is 9. Let's take a look at the graph now. So when we graph this exponential, again, all we have to do is plot the points. So -2, 9 means you go left 2, up 9. -1, 3 means you go left 1, up 3. 0, 1 means you don't go left or right, you just go up 1. That's our y-intercept. 1, 1/3, this is where a lot of you were falling down the other day. You had the chart right, but you plot this below the x-axis. No, no, no. You go right 1, up 1/3. So just a little, 1/3 of the way between 0 and 1. That's all you're going to go. And then 2, 1/9, you go right 2 and you go up 1/9. And so this is where it gets really hard to graph at the very end because the numbers get so tiny. Your pencil lead or your pen lead becomes thicker than the marking needs to be. But you get the idea that this one is decreasing. So when the b value is between 0 and 1, you notice our exponential curve is decreasing when our a value is 1. When that b value is greater than 1 and our a value is 1, we have a curve that is increasing. All right, 2 more. Our function is f of x equals 3 times 2 to the x. So now we're giving you an a value that's not 1. What's the a value? It's 3. A value is 3. So it's f of x equals 3 times 2 to the x. 2 is the b. All right. So we got to follow order of operations. Remember that. So order of operations, you're going to do the exponents first before you do multiplication. Some of you were falling down there. I think some of you were going 3 times 2, and then you were raising it to the exponent the other day. Don't do that. So you're going to take 2 to the x, get that number, and then multiply it by the 3. Let's start with the easier one. Let's start with x equals 2. What do you get when you substitute x equals 2? I hope you got 12. The way we did it, you go 3 times 2 to the second power. 2 to the second is 2 times 2, which is 4. So then it's 3 times 4, which is how we... All right, I hope you got 12 for f of x. So it's 3 times 2 squared. 2 squared is 4, so it becomes 3 times 4, which is 12. Now try input x equals 1. Should have got 6 here. It's 3 times 2 to the first power. 2 to the first is just 2, so it's 3 times 2 is 6. All right. Ooh, what's going to happen now when we have 2 to the 0 power? What do we get? So here you get a great example why the a value is always our y-intercept in these problems. Because 3 times 2 to the 0 means 3 times 1, and 3 times 1 is 3. So our y-intercept is 0, 3. All right, let's do the challenging ones. Can you handle x equals -1 on this problem? So on this one, you have 3 times 2 to the -1 power, which becomes 3 times 2 to the 1/2 to the first power, which is just 3 times 1/2. So our answer is 3/2. You might have said 1.5 or 1.5. Those are all the same thing. All right, last part. Can you substitute x equals -2? What do we get? So 3 times 2 to the -2 power becomes 3 to the 1/2 squared, or second power. And 1/2 times 1/2 is 1/4, so it became 3 times 1/4, which is 3/4 is our answer there. So now we're going to graph it. So here's our exponential curve. Again, we just plot all the points, x comma y. So for the first one there, the green one, -2, I go left 2, 3/4 means I go up 3/4, so 3/4 of 1. So it's closer to 1 than it is to 0, and it's hard, again, it's hard to be real precise there with the thickness of the pen. Then -1, 3/2 means I go left 1, up 1.5. There's my yellow point. My y-intercept 0, 3, boom, 0, 3, pink point. Then I go right 1 and up 6. Again, did you notice my scaling on the graph? So every on the x-axis it's scaled by like 0.25. So that's why I'm going over 4 boxes. It only represents 1. And my y-axis is scaled by 1s. All right, and then to get to 12, I go right 2, up 12, and there's my exponential curve. I can't do it on my computer right now to make it nice and pretty, so I'm just giving you discrete points versus drawing out the curve. Now it has an asymptote, right? If I keep going left, I approach the asymptote, right? It gets so close where it virtually looks like a line to our naked eye because we can't see anything else. It looks like it's going straight, but it's actually going down a little bit each time. Okay? All right, one more. Here we have f of x equals 4 times 1/2 to the x power. So our f of x equals a times b to the x. So our a value this time is 4. Our b value is the 1/2 and to the x power. So this one we expect it to be decreasing because my b value is 1/2 and my a value is positive. So let's take a look at this one. I'd like you to, let's again start with the harder ones. Let's start with the -2 power. Substitute that in. What do you get for f of x? When we substitute -2, we should get 16 for y, or f of x. So 4 times 1/2 to the -2 becomes 4 times 2 to the second power. 2 to the second power we know is 4, so it becomes 4 times 4, which is how we got 16. Try it again with -1 as the input value. I hope you got 8. 4 times 1/2 to the -1 power becomes 4 times 2 to the +1 power, which is just 4 times 2, which is how we got 8. All right, let's do it with 4 times 1/2 to the 0 power. What do you get this time? So I hope you got 4. As 4 times 1/2 to the 0 power becomes 4 times 1, which is just 4. So again, this is our y-intercept. The a value actually represents the y-intercept at 0, 4. Let's do the next two together real quick. 4 times 1/2 to the first. Wasn't that just 4 times 1/2? So that's 2. And then 4 multiplied by 1/2 squared. Wasn't that 4 times 1/2 times 1/2 is 1/4. 4 times 1/4 is 1. So now we're going to graph it. So you're staring at the graph. What are we going to do? We have our table of values. What do we do? Think to yourself how you're going to graph this. So the graph, the first point, -216, from the origin, 0, 0, we go left 2, up 16. To graph -1, 8, from the origin, 0, 0, we go left 1, up 8. To graph the y-intercept, 0, 4, we don't go left or right from the origin, 0, 0, we go up 4. To graph the point 1, 2, we start at the origin 0, 0, we go right 1, up 2. The last point, my mugshot here gets in the way. How would you graph 2, 1? We go right 2, up 1. So the curve's coming down, and it's going to create an asymptote right at the x-axis. It's going to be, again, so close, but yet so far from the x-axis. I hope today's lesson was helpful for you, gave you some immediate feedback. If you're making any mistakes, that you can catch those mistakes. If you're doing well, it kind of gave you a pat on the back that, all right, I got this, I'm doing well. Let me know how this lesson worked out for you, and have a great day or morning or evening or late night. We'll see you next time.